Hello, Tom again. In this video, what we're going to do is we're going to look at creating our own generic classes. So we'll be doing our coding in the program class in a static method called part for generic classes demo. So that's where we'll be doing a lot of coding. But there's another source code file I'll get you to open, which is pairing.cs. So rather than create a brand new class from scratch, I've created one for you to start with. This is not a generic class. So this class is called pairing, and what it represents is an object that contains two other objects. It just binds them together. Okay, a very simple container type object, not quite a collection object. A pairing object has two properties, a left and a right. And you can see here I've got, just basic sets and gets for my left, which is a private field, and my right, which is a private field, and public properties. Okay, both of these properties are object properties. So I'm able to actually store, left and right, any kind of object I want, including value types. There is a parameterized constructor, okay, that takes two object parameters and essentially sets the left and right properties to those parameters. There is a default constructor, so I can create a pairing object without setting the left and right, and that just keeps them null if that's what happens. I have some fancy stuff here. In this particular case, I am overloading the array list operator. So if I want to typecast a pairing object as an array list, this does the conversion. So internally I create a new array list. I add the left, I add the right, and then I return that new array list. Okay, so that's one thing I can do with a pair. If I want to sort of upgrade it to an array list, that's kind of the idea. Because it really is just an array list light, isn't it? Just with two elements in it. And then I'm overriding the toString simply just to output the string, the left property converted to a string, and the right property converted to a string. So that's my basic class. It was about as basic a class as I could figure out to demonstrate what we want to demonstrate about generic classes. But again, I just want to emphasize this is not a generic class. So let's go back to the program class in the part 4 generic class demo. We'll create one of these objects. Okay, so underneath where it says unconstrained example, that's as good a place as any to put this. We'll create a pairing. Okay, so a pairing, I'll call it test pair, something along those lines, equals new pairing. And we'll just arbitrarily, set it to two things. Maybe a string is the first thing. Okay, and then maybe the next thing is a new Cartesian point or something like that. Not Cartesian point. Let's do a new grade. Sorry, I'm getting my tutorials mixed up here. Okay, and yeah, I'll just do an empty grade, whatever. It doesn't really matter. Okay, so there is my pairing object. And if I want to actually show the pairing really quickly, I can do that kind of thing with a, console right line. Oops. I'm probably going to delete this code later on, but just to show it for now, it's called test pair dot toString will be explicit. All right, so let's try that out. Okay. All right. So it's number 4, hello world, and you can see my empty grade. So the class actually is functional and it works, but it's not ideal. And the reason why it's not ideal is, again, I'm dealing with the pair of things inside of pairing object that it contains. These are just objects, and I'm using subtyping to make this work. I can have any type of object in either one of those properties. So I could, for example, actually change, so I can take test pair, and I'll change the left hand thing to something other than a string. I'll make it, I don't know, a number. Oops, oops. Okay, and try writing it again. And I'll go ahead and run that. And we'll see if it does what I think it's going to do. So it's option 4. All right, so the way that the class works right now is I can change what the type is for the left or the right, and that might not be suitable for my purposes because I may want to, once I actually create the object, I may want those types to stick, to be strongly typed. I might want to make pairings that are specifically restricted to, say, a string and a grade, or uh, a grade and a Cartesian point, or something along those lines. So to do that, what I want to do is I'm just going to more or less comment all that stuff out. What I want to do is I want to modify my pairing class so that it's actually going to be a generic rather than the type of object that it is right now. So to designate it as a generic, what I'm going to do to the add to the class definition is some angle brackets, and I'm going to specify identifiers for the various types. So I want to be able to have two separate types, one for the left and one for the right. So I'm going to call one of the types T1 and the other type T2. Okay, the rules for these type identifiers are more or less the same as any identifiers. In C#, typically we, it will vary. I've seen it done different ways, but uppercase T and then numbering them, or uppercase T and then giving it like a meaningful name if you can think of one, or just more. I've seen this more in C++ using an uppercase letter other than T. But at any rate, different things you can do. So this says that I have the capacity of having two different types. Okay, the first type being T1, the second type being T2. So my left object, what I want my left object to be is not necessarily an object, but rather that first type. Okay, so I'm going to change that from being object to T1. All right. I'm going to do the same kind of thing for my right property, but I'm going to use T2. So that the way that I've set this up, the left and the right don't have to be the same type. Okay, so that's fine. Now my constructor is complaining right now because I'm still dealing with a constructor that takes two objects, and I don't want to do that. I could keep them as objects and explicitly typecast here, but what's probably a better thing to do is just simply change the types of those two parameters to my my type parameters T1 and T2. So that fixes that problem. Now, in my default constructor where I was saying left equals null and right equals null, that was okay before when left and right were objects, because objects can be null. But if my type when I actually create a pairing object using this generic class, if T1 happens to be double, for example, double is not nullable, so this won't actually work. So it's complaining to me saying, hey, T1 could be non-nullable. T2 could be non-nullable. So I have to have some alternate syntax here. So what I'll do instead of null is I want to use the default for whatever type it is. So if it's a value type, it'll be default to 0, and if it's a reference type, it'll default to null. Okay, so the syntax for that, instead of saying null, is using the keyword default. Okay, default for whatever T1 is. Okay, so if T1 is a value type, left would be made equal to 0. And I'll do the same thing. This time it's T2 for the right. Okay, so that should clear up those two problems. If I keep on scrolling down, it's complaining now on my explicit operator here, the one for array list. It's saying, hey, there is no such thing as a class called pairing. It's actually a template. So I need to qualify that. It's a pairing T1, comma T2. So I have to actually specify that it's a generic type. Okay, so it's a generic type that matches T1 and T2. And everything else seems to be okay there. All right, so those are basically the changes I needed to make to the pairing class to convert it from a class into a what I would call a class template, but rather in C# normally known as a generic class. So let's go back to, I'll just save that. We'll go back to program, and we'll play around with the new pairing generic class. All right, I'm actually going to delete these lines. So underneath unconstrained example, what I'm going to do is I'm going to create a couple of variables, maybe an integer and a double, that I'm going to use to pair together. Okay, so there'll be two numeric types, an integer and a double. Okay, arbitrarily set them to 8 and 9.9, whatever, it doesn't really matter. And then I'll actually create a pairing. So I'll call it, sorry, it's pairing, but I have to specify the type. So the first type for my pairing is going to be an int and a double. Okay, so that's the actual thing I'm creating. I'm going to call it a numeric pair. Okay, that's the identifier that I'm going to use. And I'm just going to call the default constructor. So new pairing, and then obviously it has to match. It's a pairing int double. So that's a specific implementation of the generic class pairing. Okay, so that actually creates the pairing object and dynamically creates that class. All right, so underneath where it says set the pairing properties, this is where I'm going to actually set them. I'm going to set them to these variables. I don't have to do it that way, but that's what I've elected to do to show you something else in a second. So it would be numeric pair, dot left equals some whole number, for not some real number, some whole number. Now, since integers obviously are value types, what ends up happening here is some whole number is copied into the left property. Okay, so the left property is going to be 8, but it's a copy. So if I change it later on, it shouldn't actually affect the original. If I change some number later on, it shouldn't affect left. They're not linked together. Okay, like a reference type is. Okay, I'll do the same thing with right, except I'll make it a real number. And let's show the pairing. Okay, and I'm just using concatenation this time to be different. So I'm going to go ahead and run that, and just to make sure that everything works. So again, it's number 4. So numeric pair is 8 followed by 9.9. So that seems to have worked. And just to prove that this is working with the value types, I'm going to modify my two variables. I'll make them 88 and 99.99, and then I will output it again just to verify that the pairing hasn't changed. Okay, so let's go ahead and run it this time. So 4, and I can see that even though I changed, what I was, the underlying variables, or the variables, some whole number and some real number, I changed those. It didn't affect what was being stored in the object because they're value types. So that kind of makes sense. Alrighty. Now that's not always going to be the case. I'm going to create another pairing. Okay. This time the pairing I'm going to use, let's say I'm going to pair together a grade and a string. Okay, and I'm going to call this pairing, let's say, grade feedback. Okay, so the string is going to be some indication of, what the grade is. Is it good or bad or something along those lines. Okay, so I'll make that equal to, and I'll just use the default constructor for this type of pairing. Okay, so again, I have to specify the types. So grade and string, I think I said. All right. There's a comment in mine here about I do basically another thing, a precision point, but anyway, I'm going to get rid of that. It shouldn't be in yours when you're looking at this. Forgot the word new, that's why I'm getting that error. There we go. So that should go away. So I'm creating a completely new object here. But what I want you to recognize, it's a different class too. Yes, it is still a pairing, but it's a pairing of grades and strings as opposed to a pairing of ints and doubles. So it's still strongly typed. Like before, I'll create a couple of variables here. I'm going to create a grade. We'll call it the grade, or some grade, I think will be consistent here. Some grade equals new grade. And I'm going to make it a great grade. We'll say 24 out of 25, let's say. Okay, so that's what some grade is. And I'm going to make a string, and I'm going to call it some string. Not feeling super creative. And equals. And I'm going to make it equals to, I don't know, star star, all in caps. Outstanding. And a few more stars. Lots of emphasis there. All right. So again, I didn't necessarily have to have these things separate from the pairing, but that's what I wanted to do. I'm going to take the pairing and I'm going to set the left and the right. Okay, so it'll be grade feedback. Oh, my caps lock was still on there. On the left, I have a grade, so that will be equal to some grade, let's say. I got to turn off my caps lock. All right. And on the next line there, I'm going to take my grade feedback, and my right equals, and I'm going to use some string. All right. So we'll try that out. Okay, we'll show the pairing again. All right, so grade feedback is grade feedback. Let's try running this at this point. Okay, so I can see, it's a grade converted to a string followed by the actual string, so that seems to be working fine as well. I'm going to add one more space there to make it line up the way I want it to. There we go. Like the previous example, what I'm going to do is modify each of the, I'm going to modify some grade and some string to see if it has any effect on the object. So I'm going to say some grade dot score is equal to, it was 24 before, now I'm going to make it, I don't know, 5 arbitrarily here. Okay, so it's clearly a lower score. And I'm going to take my string, some string, and it was outstanding, and now I'm going to make it, needs work. Okay. All right, so let's check to see if the pairings changed. I'm just gonna cheat here and just copy that output of grade feedback and paste it, and I'm gonna add the word now. We'll see if that makes a difference. So I'm gonna go ahead and run this. And again, it's number 4. So it didn't behave quite exactly the same way that my numeric pair one did, because I'm dealing with 2 objects here, or two reference types. Strings are kind of weird, but objects are reference types. So when I changed the object, it changed it in both places because I only had one actual grade. The string didn't change, which is maybe a little bit counterintuitive, but strings are, although technically they are reference types, they are immutable, meaning that they're set up in such a way that they're kind of almost like read-only. They behave more like value types for stuff like this. So just demonstrating the difference, and maybe a bit of a weakness in my generic template, it does require that I know what I'm doing. Now that leads into another topic that relates to generics, and that is setting some constraints on what these various types can actually be. So what we're going to do is we're going to pop back into the pairing class, and we're going to specify some constraints or restrictions on what each of these types can be, so that I'm able to, if like for example, if I know coming in that T1 has to be a reference type, or it has to be a value type, or whatever, then I'm able to do things in my actual code that I'm not otherwise able to do. Okay, so like right now, I don't know whether T1 is by value, whether it's nullable, whether it supports a particular interface or anything along those lines. So I'm very limited in terms of the code I can add in here. So let's talk about a few of these constraints. So where you actually specify constraints is right there where you're defining the class. Where is the keyword, and then you would say, you know, T1, for example, if that's the one that we want to deal with for now, a colon, and then you're going to specify whatever the restriction are. You do have a number of different options here. So if I wanted to say, okay, T1 has to be an object type, I would actually say class, okay? And that would basically restrict T1 to being a class type. If I go to build that, I don't actually think I need to, it's already come up. By adding in that restriction, now it's complaining back in main on the pairing that I had that only allowed, or that I tried to pair an integer and a double, because integer is not a class type. Okay, so it's preventing me from doing that. All right, now if I do make that specification, then I can do stuff like, I'm struggling to find the example off the top of my head. We'll come back to that. But at any rate, I could do things in my code if I, you know, if I know for sure it's a class. There might be some things I can do in the code that make sense only for a class. Some other options here. The opposite of class is saying, well, I want it to be a value type, so I could say, and you use the word struct if you want it to be a value type. So now you can see I changed class to struct. I'm getting different errors now. Let me just rebuild it to make sure I'm getting the right errors. Okay. So it was okay with int, but now it's stuck on grade and saying, well, grade's not a struct or a value type at all, so that's not working. Okay, so there are these different options. Sometimes you'll see it, by the way, in the code specified this way. So let me run through a number of options for you. All right, so I've got these as comments, but yeah, so class, this would restrict T1 to an object type. Struct, as I said before, constrains it to a value type. I could say that it's constrained to a particular class or child class. So if I were to say, for example, where T1 equals grade, it would only accept in that first position grades or objects that inherited from, or classes that inherited from grade. Okay, so that would be a very useful one. You can specify things like interfaces. So this isn't saying that T1 has to be a particular class, or even that it has to be a class. It could be a structure, but it has to support the iClonable interface. Okay. If you are specifying multiple ones, has to be the last one, but when you say new with brackets, that says that whatever T1 is, it has to have a default constructor so that you can use the default constructor. Okay, so those are your various different options. You can also say, this is I think called a naked constraint, where you can say a certain type, like T2 has to be either the same class as T1 or a child class of it. Okay, so you can use one type parameter as a constraint on another one. Okay, that's possible. And then you can also specify multiple constraints. So in this example here, I'm saying T1 has to be a class, it has to support iClonable, and it has to have a default constructor. Okay, so I'm going to leave that multiple one in, and I'm just going to rebuild it. It's going to complain about my integer version, so I'm going to go back to program, and I'm just going to comment this out. I'm going to leave it in, but the whole unconstrained example, all of those lines, I'm just going to comment those out so that I don't I don't have the problem anymore. I will build the solution. You can see I've got no errors this time because a grade actually is a class. It supports iClonable, and it does have a default constructor, so it actually meets all of those criteria. All right, now once you've actually set constraints on your parameters, then again, you're able to do more in your class code-wise. So a relevant example in this class is instead of in my left parameter, I'm only constraining the first type, so it's really only the left parameter that's going to apply. Rather than just making it equal to value, I can take advantage of the fact that I know that the type coming in supports iClonable, so I can say something like my left equals value dot clone. Okay, I wouldn't be able to say that unless it's constrained. Okay, because not everything will have a clone method. Now it's complaining here because I need to either typecast it or I need to say as. So it's as a T1. Clone, you'll recall, returns an object. Okay, so that's one example. I'll do the same kind of thing in my parameterized constructor here. So instead of left equals left, well, actually I shouldn't need to do that because I'm using the property, so that's going to call this property the set for that property anyway. So that's fine. I'll just leave it the way that is. For the default constructor, though, I don't want to leave it as the null. What I want it left to be is a new object if one isn't specified. So I can say left is equal to a new T1. Okay, and I wouldn't be able to do that if I didn't know that T1 had a default constructor. And I know it does because I've constrained it to only accept things that have a default constructor. All right, so now that I've made those couple of changes, notably, if I go back to program, when I changed the score for some grade, now that I'm cloning it instead of just copying it over, because I can do that with that constraint. If I go ahead and run this, we'll see if there's any difference in the output. So it's generic class demo. Now you'll see the difference that the grade feedback didn't change even though I changed the underlying grade. Okay, so that was a refinement I was able to make by constraining the types I was dealing with in the generic class. Okay, so that wraps up what I wanted to talk about in terms of creating our own generic class. There's a few other details in the book that you can review. It's just really an introduction. This was a bit of a long video. I apologize for that. In the next video, what we'll do is we'll have a nice short one just looking at a generic method. So not a method that's inside of a generic class, but a generic method inside of a regular class. All right, thank you very much.